Hello everyone, this is Zhao Chen from King Abdullah University of Science and Technology. I'm presenting our work, SegTAD, Precise Temporal Action Detection via Semantic Segmentation, co-authored with Murray, Meng, and Bernard. Temporal Action Detection, TAD, is one of the most fundamental and important tasks in video understanding. It requires to recognize what types of actions are in the video and to localize when the actions start and end in the 1D temporal domain. Most existing TAD works draw inspiration from image-object detection, which recognizes and localizes objects in the 2D image domain. Following object detection, they usually formulate the TAD problem into the two-stage framework of proposal generation and classification. However, in detection, training samples, namely anchors proposals, don't have out-of-the-box ground truth labels. The annotations just tell what actions happen and when, but don't include labels above the samples, which are generated on the fly and are not bijectively aligned with the ground truth actions. Instead of using the annotations the same way as in object detection, we can map them to segmentation labels. In 2D images, as shown on the right, object detection and segmentation labels encompass different areas. But in video sequences, temporal segmentation labels can be obtained from detection annotations with zero effort due to its 1D property. Based on this, we propose the following semantic segmentation-inspired TAD framework, SegTAD. This is the architecture of SegTAD. It follows the two-stage detection framework, but reformulates the first stage as a semantic segmentation problem, aiming to predict a class label for each snippet. The second stage is a detection task, aiming to predict the class label for each proposal. In stage 1, 1D semantic segmentation network, we design an hourglass architecture, which contains an encoder and a decoder. The encoder aggregates snippets in the temporal dimension via threaded 1D convolutions, and the decoder progressively upsamples the snippet sequence in the temporal dimension via interpolation and 1D convolutions. To connect the encoder and the decoder, we design parallel A-trace convolutions with different dilation ratios, and a graph network that models each snippet as a node. The loss in this stage is per frame classification loss, implemented with cross entropy. In stage 2, the proposal detection network, we construct a proposal-level graph network where each proposal is a graph node, and proposal-proposal correlations are the edges. It predicts the confidence score for each proposal. The losses try to minimize the difference between the predicted confidence scores and their labels. In the experiment, we compare the proposed SegTAD to representative methods in the literature on two large-scale datasets, ActivityNet and HAX. SegTAD shows its obvious advantage in terms of average mean AP on both datasets. These figures show how good our segmentation results are from stage 1. The green curves represent the ground truth actions, and the purple ones show the predicted confidence scores at each snippet. We can see that for both videos with long actions, as in the left figure, and videos with multiple short actions, as in the right figure, our predictions clearly match the ground truth. In conclusion, we formulated TAD in a novel perspective of semantic segmentation and proposed a unified TAD framework, SegTAD. We incorporated graph networks for both snippet level and proposal level correlations. SegTAD showed promising performance on two large-scale datasets. Thank you